let's do a couple of exercises to practice using our angle rules and the idea of sums of angles inside and n-gon to solve for some angles. So here's an example. Let's do this one. Let's find the measure of angle x. Here's x here. So we're looking for this angle right there. So pause the video and see if you can use your angle rules to determine the measure of angle x. Okay, now that we're back, let's talk about a plan. So right now, what do I see? I see two parallel lines. I know that that can be helpful. I can use the parallel x rule to move corresponding angles to the other x. That's fantastic. I notice that this is indeed a triangle, so I can use that as well. So I have an angle of 50 here. Using the parallel x rule, I can move it in here. And then I have two angles of a triangle, and that third angle is here. So I could just, in fact, use the fact that the angles have to sum to 180 to solve for the angle of x. Alternatively, kind of doing the same thing, and we'll talk about why this is the same thing in a few lectures time, but we can move this 60 degrees down here, and then we have a big triangle, and we could do the same thing. We could solve for the angle x because we know those angles have to sum to 180 degrees. So let's go ahead and do that. So the first thing we're going to do, by the parallel x rule, we are going to move that angle up here. So we'll say here, parallel x rule. Okay. And now we know that 50 degrees plus 60 degrees plus the measure of angle x has to be 180 degrees since we have a triangle. So I think we can do this quite quickly. This is 110 degrees, so this must be 70 degrees. If you don't see that, you could just solve that little equation there. So this tells me that the measure of angle x equals 70 degrees. So we found the measure of angle x. It was 70 degrees. And we can say by angle sum of triangle. And there we go. So we found the angle x. Here's one that's slightly harder. So I want to find the measure of angle z here, which is right here. So this one you'll have to do a little more puzzling, but pause the video and see if you can figure out how to find this angle. Okay, so let's come up with a plan of attack just like before. So I notice first of all that I do have another set of parallel lines. That is good. Whenever I have parallel lines, I know I can use that parallel x rule. So there's a good chance I'll be using that somewhere. I note that kind of this angle z isn't part of any triangle or anything like that. We're open on this side. So I can't use any information about, say, this angle or this angle directly. But if I know, say, this angle here, I can use the x rule to solve for the measure of z, since these guys are definitely supplementary. So that's my goal here. Okay, so let's figure out some angles. Maybe I can put some angles in here. If I figure out two angles in this triangle, I can figure out the third one and then use the x rule. So that's going to be my plan of action. The first one is quite simple. You can see right away via the x rule. Here's a vertical angle to 50 degrees. So this guy is 50 degrees by the x rule. Okay. Now, we can use the parallel x rule. So, erase this guy here in your mind to be left with a situation that looks something like that. We know this angle is 155. So, via the parallel x rule, we know this angle is 155. So let's put that in. This is 155, and that is by the parallel x rule. Great. Now that I figured that out, I can use the regular x rule to determine this angle. These guys are supplementary, so let's put that in there. So if I subtract 180 minus 55, I get, minus 155, I get 25 degrees. Okay. So this angle is 25 degrees, and that's via, and maybe I'll put a little kind of arrow here just to remind me how I got that. So that's via the x rule. And really I should put an arrow here to remind me, and maybe here as well. Okay. And then finally, well, these three angles sum up to 180 degrees. So I know that this angle and this angle is 75 degrees. So a little bit of easy arithmetic should tell you that this guy is 105 degrees. Maybe I'll put some arrows in here to say how I figured that out. And that's via angle sum of a triangle. Great. And then finally, well, if this guy is 105 degrees, this guy is definitely an adjacent angle to it. Here's our x. So this guy has to be 75 degrees. So this here is indeed 75 degrees. And I'll put a little arrow here to remind myself how I got that. And that is via, again, the x rule. So you can see that using our parallel x rule and the x rule, and the fact that the sum of the angles of a triangle is 180 degrees, the angles here are a set of supplementary angles, then we can use that information, all of those things, to solve lots of different angle problems.